So let's take a look at this question. A man leaves his home, walks at a speed of 12 km per hour, reaching the railway station 10 minutes after the train had departed. Okay. If instead he had walked at a speed of 10-15 km per hour, he would have reached the station 10 minutes before the train's departure. The distance in kilometer from his home to the railway station is. Now, to solve this question, there are two approaches. The first approach is the equation method. I'm quite sure that a lot of people will find comfort in this method. Let's see. In the first case, the man, this is the, let's say this is the distance. Okay. This is the distance from his home to the station, right? The railway station. And we have his speed, which is a 12 kilometer per hour, right? 12 kmph. Let's say this distance is d. Now it is given that he reaches the railway station 10 minutes after the train has departed. So let's say train departs at t time after he starts from home. So t time plus 10 minutes, right? This is in minutes. Just remember this, because if you convert it into hours, there is a lot of difficult answers that you will get. Instead, just be mindful of the units. So the equation here becomes distance is equal to speed into time, t plus 10. In the second case, we know that in the same distance d, the man starts from his home and walks at 15 km per hour, right? And reaches the station before the train's arrival, say train's departure. Now we saw, we assumed that the time after which the train departs when he starts from his home. Let's say he starts at 00 from his home, then after t minutes the train departs. So if he reaches at 10 minutes before the train, so it becomes a 10 minus t minus 10 minutes. Again, look at this. I made a mistake which I was telling you about. Be mindful of the equations. This is in minutes, t by 10. I need to divide it by 60. Okay. Now, we write the same equation for d in the second case, which is 15. Speed is 15 into t minus 10 by 60. Let's solve this equation because we have two variables. D equal to 12 by 60, t plus 10, and d equal to 15 by 60, t minus 10. So we will just solve these equations. We have got two equations. We can directly equate because they are from d. We can figure out the time. So 12 by 60 is into t plus 10 is equals to 15 by 60, t plus t minus 10, right? Just 60 cancels out. 3 4s are 3 5s are, so it becomes 4t plus 40 is equals to 5t minus 50. 50 goes on this side, becomes 90. 50 plus 40, and this becomes t. So I have got the time, which is 90 minutes. Fair enough. Now if I get the time as 90 minutes, I just put it in any of these two equations. I will get my distance. So distance is 12 by 60 into t is 90 plus 10, which makes it 12 ones are 12 5s are 60. Fair enough. So this becomes 100. So 100 by 5, distance is 100 by 5, which is 20 kilometers. That's your answer. The 20 kilometers. That's my answer. So I told you there was second method as well. So let's look at the second method. Let's take the first case. So this is my first case. This is distance d. He is started from his home at 12 km per hour speed, and he reaches after the train departs. So time t plus 10. In the same way, we draw the second case as well. He reaches 10 minutes before the train departs, and he walks from his home at a speed of 15 km per hour. Now, distance is equals to speed into time. So if d is constant, s into t is constant, s is inversely proportional to time. Is this okay? If this is okay, then speed is inversely proportional to time. Then the law of percentages applies here. So in percentage terms, 3 kilometer was increased over 12 kilometer per hour. So this was an increment of 1 by 4, right? This was increased. Then decrease should be 1 upon 1 plus 4. The decrease in time was 1 by 5. The time difference between these two is 20 minutes, right? 20 minutes was the time which was decreased, because this is t, let's say. So this is the t minus 10 and this is t plus 10, right? So this is t plus 10. In between them there is 20 minutes difference. Now this is more. The first case was more and it reduced. This was more, this is less. So it reduced by 1 by 5. So the time that was reduced was 20 minutes and it was equivalent to 1 by 5 of t, right? It was 1 by 5 of t, which was the initial time frame. Sorry for this, initial time frame. Always take this as the time frame. This was the initial time, right? We took this as a case 1, this as a case 2, and on this there is a 20-minute difference. So 1 by 5 of t plus 10, this goes here, t plus 10 becomes 100. I have t plus 10 into 12 is equals to d. I get 100. I'm sorry, there is a mistake here. So if I get t as 90, right? I get t as 90. Fair enough. Now what we did here is the same thing that we did here. We have got the same time, if you notice, right? So we'll just input that same thing, d equal to 12 by 60 into t plus 10, which will again give me 20 kilometers. Because this does not require any variable, so this method has no variables, and this method has no complexity. It is quicker. It is quicker. So I hope this is the method that you use in the exam. I hope you like this. I'll see you in the next one.